Toss your phone spinning flat. It turns clean. End over end. Clean. But spin it about that third way and it flips. Every time. That's not clumsiness. Every object has axes it's happy to spin about, and one it isn't set entirely by how its weight is spread. A phone is just mass, spread through space. So is your data a cloud of points. Center it on its average, the mean. Its shape is the spread, the covariance, how far and which way the data reaches. And the axes it's happy to spin about are the principal components, the eigenvectors of that spread, always at right angles. Point any direction and ask, how spread is the data along it? Sweep around the spread peaks on the fattest axis. That winner is the first component, the direction of maximum variance. And how fat each axis is its eigenvalue is just the variance along it. The clean axes were the fattest and the thinnest. The one that flips is the one in between. When two axes are nearly as fat as each other, which one PCA calls first, gets shaky, they can swap. In a perfectly round cloud, it has no favorite axis at all. Line the axes up with the body's own, and something clicks. In its own frame, the spread is diagonal, the axes stop talking to each other. The new coordinates are uncorrelated. Rescale each to match, and the cloud turns perfectly round, whitened. Here's the whole trick. Keep the fat axes project onto them, and every point gets new coordinates. The scores, the little that pokes out along the axis you dropped, is all you lose the reconstruction error. Widest kept and least lost are the same choice. Rank the axes by how fat they are, the eigenvalues. Largest first, the scree. Each bar is the share of spread it holds. Keep just enough to hold most of it. The rest is a thin, ignorable wobble. Weight one end, and the body's favorite axis swings toward it, not because that end matters, but because it's heavy. Measure one feature in big units, and PCA does the same. The fattest axis is just whichever you measured in the biggest numbers. So first put every axis on equal footing, standardize. Here the spinning stops, and I'll say so. A computer never forms the spread matrix, it factors the data straight. X equals U sigma V transpose, the singular value decomposition. V is the very same axis. The stretches sigma are the square roots of the fatnesses. Faster and far steadier. Two honest limits, and neither is a tuning mistake. PCA keeps the axes the data leans on, but the direction that matters can be a thin one it throws away. It ranks by spread before it ever sees your question. And its axes are straight, give it a curved cloud, and it drives right through the bend. That's not a setting you can fix. It's where other methods begin. Some shapes simply bend, and a straight answer, however clever, will always cut the corner. Knowing when your data is straight enough, that's half of using this well. So, find the axes your data is happy to spin about the eigenvectors of its spread. Rank them by how fat they are, the variances. Keep the fat, drop the thin. It goes by a dozen names, loadings, and scores. Empirical orthogonal functions, proper orthogonal decomposition, a truncated singular value decomposition, one move under all of them. So the next time your phone flips out of your hand, you'll know it was never clumsy. It just has axes it was born to spin around. So does your data. Every dataset has axes it leans on. PCA finds them, it just can't tell you which ones matter.